Hello YouTube, it's Tobey, back from the dead. And today's video is going to deal with a very common question that people might not know the answer to at first. And that is, what are the differences between C and C++? A lot of my friends have asked me this question, and me personally, there was a long time where I didn't know the answer. Fortunately, we live in the age of, YouTube and the internet, and sharing information is as easy as it's ever been and easier than it's ever been at the same time. So I decided, let's make a video in a PowerPoint and explain a lot of what the key differences between the two are. As I mentioned, I have a slideshow. In addition, I have examples for each of the points I'll be making. It shouldn't be a super long video, but by the end, you should definitely know the difference between C and C++, and we'll have a clear sense of which one you want to use for your upcoming project. That being said, let's get started. The major difference between C and C++ is that C++ enables object-oriented programming. C++ is also a superset of C. C is a procedural language, but it doesn't have object-oriented programming features. C++ has both. For starters, C++'s original name was actually C with classes. Classes, as you might know, allow you to define your own types within the type system with their own additional functionality in the form of methods. So instead of having to, have consumers of your API or within your own application, instead of having them consume like opaque struct pointers, you can actually give them instances of a concrete type and they can interact with that instance. Classes in C++ can also have what are called constructors and destructors. These are special methods that will either initialize or destroy an object when it goes out of scope or is deleted. So let's cut to the example. So the first example is, as you can imagine, an example of classes. This is a simple class with my name, Tobey. I have a definition right here. Notice that it ends in a semicolon. I have the name of a class. I have a single method declared as being public. This means that anyone can call it if they have an instance of Tobey. So the definition of that method just returns 19, my current age. So my program entry point just creates an instance here. You'll notice that just as if I were declaring a struct in C, I just declare the type name and then give the instance itself a name. I don't have to use the new or delete syntax. We'll get to that in the 6th slide. So as you see, I have my instance and I call the getAge method that we just defined, return 0 and exit. For the next, so one term you might hear, you definitely will hear a lot when working with C++ is RAII. This is short for Resource Acquisition is Initialization. That might sound like a lot of fluff at first and a bunch of big words, but in reality, it's just like a convention that allows you to encapsulate data within a block scope. And when used properly, this can simplify resource management. This doesn't exist in pure C. For example, you have to call like fopen and fclose whenever you're interacting with the file. Whereas in C++, you can create an instance of an IFS stream, an input file stream, and you don't have to explicitly close it. As soon as it goes out of scope, it will be closed by itself. So next example. So like I mentioned, I used the IFS stream as the example here. Obviously, this condition for the if statement will evaluate to true in every case. This is just to demonstrate a simple block. So this input file stream exists only within this if statement. As soon as we exit, it's closed. That is that's RAII in a nutshell. Obviously, there's some more nuance to it, but I don't think that's very necessary to get into right now. So next is the sender template library. I'm not gonna go full screen again because it's a little inconvenient, So the full name of the STL is the Standard Template Library. In the C++ preprocessor, there's a feature added called templates, and these are more advanced than simple like pure C macros, in that C++ templates can have parameters. So like you can you can kind of use them as if they were like generic types, but it's obviously not the same because it's a preprocessor macro only. But anyways, the standard template library is bundled with C++. It's standardized, and there are many classes that provide commonly used functionality out of the box. This is not present in C. For example, C doesn't have mutable lists. When you need to modify a list, either you create like a linked list, or you dynamically allocate your array every time you access it. So, like I mentioned, vector is included. There's something called a stack. There are maps, unordered maps. There are a lot of template classes that will simplify common operations and minimize the amount of time that you use reproducing boilerplate for things that should be simple. So here's our STL example. I chose vector. It's something that everyone uses a lot. As I mentioned, it's a mutable collection. So when you call this pushback method, it performs that task of allocating more memory if it's necessary. And one thing about a vector is it's contiguous memory instead of a linked list. So you can actually get a pointer to the data buffer held in a vector and pass it to a pure C function. Our next key difference between C and C++ is namespaces. This is actually a huge difference. It's kind of indescribable in words how much of a difference this is and the convenience that this brings about. Namespaces are really good because they allow us to encapsulate names within a scope. Something that you see often in the pure C world is you want to have like a function or like a symbol, but it has the same name as another, so you have to prefix it with a bunch of underscores. I have an example here from GNU libjit. Every function is prefixed with jit underscore, and then if you're creating like a context, then you have to also prefix it with context, blah 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 blah. So namespaces are nice because instead of having to underscore or prefix with an underscore, you can wrap everything related to your library in a namespace, and anyone using your library either has to provide the namespace prefix or use a special using namespace keyword. So here's our example of a namespace. Very simple. As you can imagine, I have two symbols here with the same name. That name is actually literally same name. It exists in a foo namespace and a bar namespace. In my entry point, I create instances of both. And also, just for effect, they each have one member with the exact same name as well. And C++ compilers are intelligent enough to know that the value of one same name is not the same value of another same name, thanks to the encapsulation provided by a namespace. Next key difference is pass by reference. You could say this is possible in C, but I don't really think it's a true pass by reference. When you're calling functions in pure C, what you do is you pass them by value. So if you have an integer, like say you had the number 3, when calling a function, a copy of that integer would be created like on the heap, and then your copy of that information would not be modified. In C, if you wanted to modify something in place, you would pass a pointer. Pointers are not really considered safe because if you don't use them right, it's easy to create like access errors and open your application to flaws if you don't take the necessary precautions. So passing objects by reference in C++ allows you to modify them in place without passing a pointer. One thing you'll notice about syntax is that in your declaration of a parameter that is a reference, you affix an ampersand that is this simple that I'm about to highlight, you affix that to the end of a variable name, parameter name, and whenever anyone calls that, it would be passed by reference automatically, rather than having to prepend, an asterisk to symbolize a pointer, and then the callee would have to prepend an ampersand. So here's the example. I'll pass by reference. So I just have a simple function. It actually does nothing, but it takes in an input stream. In this case, we will pass like standard input. It doesn't do anything, but I also have another function. It takes a reference to a struct, and so I initialize my struct and I set its initial value. But when I call this incremented function here, it increases the value on the instance that I have, but it increases it in place. So after that call, the value will be 5 on this very instance of my struct. In pure C, if I did this without passing a pointer, the function incremented wouldn't receive my exact copy of my struct. Instead, a copy of that data would be created, and the changes made to the copied my struct would not be propagated back to the original struct. So that is the benefit of pass by reference when you need to modify something in place. The next key difference is the new and delete keywords. They're not just keywords, they're actually operators in themselves. They're built into the language. You could say they're analogous to malloc and free from the C standard library, but they have extra benefits. For one thing, new does more than just memory allocation. It'll also call constructors. So if I had a class that would print hello world on instantiation, hello world would be printed. However, if I did that with just malloc, nothing would be printed because malloc is not aware of constructors. It's a compiler based feature. Another benefit is that in a standards conforming implementation of C++, the new keyword will not return a null pointer, so you don't have to have a pointer equals malloc blah blah blah, and then if pointer not equals null. You don't have to do that. However, if you do not have memory available, you'll have a bad alloc exception thrown. We'll cover exceptions in the next slide actually, but new will never return a null pointer on its own if your compiler conforms, which more than likely it does. The delete operator, on the other hand, it's just like new, but the inverse. Not only does it free memory, like the free function in the standard library of pure C, but it also calls your destructor. So just like in our earlier example, if our class would print goodbye world when it was destructed, calling delete would definitely print goodbye world, whereas if you just called free, nothing would be printed because free is not aware of constructors, destructors, or the entire object-oriented model available in C++. So like I just said, exceptions. Oh, before that, let me actually show the example. Almost forgot. So just like I said, I have a class here named myClass. It has a single member. It's a public integer named value. You can just look at the entry point. I allocated, an array of 255 characters using the new syntax. You can use it to make a dynamic array, which is nice. You can also make an instance of my class and then access it because it's a pointer. I can also create an array of my class objects, and you'll notice at the end I added this little array symbol to the delete operator. This way, not only will it free the memory of the entire array, but for each one it'll also call their destructors, which can be useful depending on the context. So if you allocate objects using the array syntax, then you should also delete them using the same array syntax. So that brings us to exceptions. Exceptions, they do have some overhead, of course, but they have benefits for error handling as well. One key difference here, I'm not necessarily going to say whether it's a benefit or not. I personally prefer it. Some people might not, but you can use this try catch syntax with exceptions, and in the try block you include some code that may or may not throw an error, but you don't have to include the error handling code in your actual try block. the error handling code is all moved to a block which is prefixed with the name catch. And catch will take a single parameter passed by reference, which extends from the class exception from the STD or standard template library namespace. So one key difference about exceptions is that since they are classes, they can include additional contextual information. That's not impossible in C, but it definitely looks different. Also, because exceptions are classes, they can have constructors, destructors, copy constructors, move constructors, all the additional features that come with classes. Also, classes work hand in hand with RAII, so it's not the same as in C because there's a lot more available when you use exceptions in C++. So here's our example of a custom exception class. You extend exception just like any other class. I just call it the myException. To get the message of an exception, you'll have to override the member function named what returns a constant char pointer. If you're using the standard string class, then you'll return the .c str member. But overall, it's pretty simple. You can see I have a try catch block. Typically, you wouldn't use a try block just to throw an exception because that's overhead. But there would be other actual logic here. And if there was something that went wrong, I'd throw an exception. Or if I were calling other code that could potentially throw an exception, I could wrap it into try block. And then when I catch it, it's passed by reference, and I can print out what happened or handle the error case. Next up is null pointer or null PTR. Pronunciation doesn't really matter, just so you know the concept. So this is different from the all caps null NULL in pure C, in that null pointer is an actual pointer. It's not just the number 0. It's built into the language itself, whereas null is included in I think the standard def.h file and is typically just points to 0. You can't implicitly convert an integer to a null pointer because integers are technically not pointers. Pointers can have a different size depending on your architecture, as you already know. So here's a simple example of null pointer, probably the simplest one in this video. So I have a function that declares that it returns a pointer to characters. In reality, it returns nothing. And yeah, null pointer is its own keyword. Speaking of pointers, we also have smart pointers. And if I remember this right, you can actually implicitly cast null pointer to a smart pointer. If I'm wrong, correct me on that, but I believe you can. I just did it like a few days ago. It depends on your compiler. But so smart pointers, they build on top of RAII, and they're different from regular pointers in that they kind of abstract away memory management. For example, if you're using a smart pointer, you won't have to call delete or like free directly on your pointer. The smart pointer will take care of that for you. The way that shared pointer, unique pointer work is that they count references to a raw pointer of data, and once the count of references reaches 0, that means no one is interacting with the data anymore. So it's safe to call delete and actually delete that data. When you use it properly, it can prevent segmentation faults and memory access errors, especially in a multi-threaded context. You might want to use a shared pointer instead of having to figure out, which thread has the last reference to this, who's going to delete it, blah, 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 things like that. Here's a small example of that. And as you can imagine, it is a multi-threaded application. If you look at the entry point, I create an instance within a shared pointer. There's a helper function in the std namespace called makeShared. It's a template-based function, so I pass some class as a parameter to the template. Any arguments that would appear in here would be passed to the constructor, which I actually did not include any arguments. Let's change that. Otherwise, this would not compile. But oops. So, like I said, any arguments that would appear here would be passed to the constructor. So then I create a thread, and my function here, threadProc, declares that it takes a shared pointer. Technically this should be like a reference type, but that's besides the point. So you start your thread, it receives a shared pointer, and as soon as the thread is done and the main thread is done, the object within the pointer will be destroyed, and you don't have to worry about, like which thread is accessing this data, so you don't end up with like a race condition where one thread destroys the data while another is using it and your application crashes. That is the utility of smart pointers, and that's more or less the entire point behind them, is to make it easier to control memory access in multi-threaded or reentrant contexts. Last but not least, I just want to mention that another huge difference in C and C++ is that a lot more is built into C++, like an unfathomable amount more is really built into C++. There's a lot available in pure C and CC and SIC, I should clarify, by default, but C++ not only provides more, but it standardizes things like mutual exclusion and locking, which is important again in multi-threaded contexts. Regular expressions, which are extremely useful in string processing, especially if you're writing like a parser, a scanner, anything like that. Strings, this is also very important. Before strings were standardized in C++, it was very common for people to write their own implementation, and now there is a standard implementation that, and just like vector, it points to a contiguous region of memory and can be used with pure C functions that expect a constant character pointer. There's also much more built in. So the example for this is obviously not that long because it would be overkill and defeat the purpose, but I've just included a few headers from the STL. Might want to check them out, like dec, a double-ended queue, a plain queue where you can add elements on one end and pop them from that end. Memory includes things like shared pointer, unique pointer, make shared, regex, regular expressions. Stack is another data structure, like a last in, a LIFO, last in first out stack. You can add an element on top, you can pop it off the top, and threading, like I mentioned as well. So all in all, those are the key differences between C and C++. Obviously, there are a lot more. There have been years, actually decades, put into C++. C as well has gone through some changes, if I remember correctly. But if you're a beginner to both languages, these are the main things you should look out for. For any feedback, just comment below. If there are any corrections that you think need to be made or any clarifications, comment below and I will be glad to do so. If you like what you saw today, please go ahead and subscribe. It would mean a lot to me. So thank you very much, and see you hopefully next week.